Hello students, and welcome back to another algebra video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, the problem asks us to write a linear function g with the values g of 2 equals 3 and g of 6 equals 5. Now remember, typically we have f of x, but g of x is the same thing. It doesn't matter if it's g of x, f of x, h of x, it all means the same thing. So if we have g of 2 equals 3, this means we have the point 2, 3. And if g of 6 equals 5, it means we have the point 6, 5. So we have x1, y1, x2, y2, and we can find our slope. Because if we want a linear function, it means we want the equation of a line, and we want it in g of x equals. But before we get there, we're going to start in point-slope form. Y minus y1 equals m times x minus x1. Okay, so we need to find m, which is y2 minus y1 over x2 minus x1. y2 is 5 minus y1 is 3 divided by x2 is 6 minus x1, which is 2. And 5 minus 3 is 2. 6 minus 2 is 4. 2/4 is 1/2. So m is equal to 1/2, which means we can plug it in. Y minus y1 equals 1/2 times x minus x1. Now, we can use either of these points to plug in for x1 and y1, but because we already named this point x1, y1, let's use this point. So, x1 is 2 and y1 is 3. All right, now remember, because we want a linear function, g of x, instead of y, we're going to use g of x, but now we need to get g of x by itself. So I'm going to distribute the 1/2. 1/2 times x is 1/2 x, and 1/2 times -2 is the same thing as -2 divided by 2, which is -1. So we have g of x minus 3 equals 1/2 x minus 1. Add 3 to both sides, gets rid of the -3 on the left-hand side, and we are left with g of x equals 1/2 x plus 2. Yeah, 3 minus 1 is 2. Perfect. And there you are. All done. Awesome. Okay. Let's move on to what we have for today. Today we're starting 4.3, so our entry task was about 4.2, but today we're going to start 4.3, which is about writing equations of parallel and perpendicular lines. So the focus today is going to be on parallel and perpendicular lines, and then in the following videos we will focus on writing equations of parallel and perpendicular lines. So, our learning target and success criteria for today is, I know what parallel and perpendicular lines are. First, let's make sure that you understand what parallel and perpendicular lines are. And how will we know, if you know, what parallel and perpendicular lines are? Well, you'll be able to identify them. You'll be able to say, yes, parallel. No, not parallel. Not perpendicular. Yes, perpendicular. You'll be able to say and identify perpendicular lines. Okay, let's jump right in. First, we're going to talk about parallel lines, and then we will talk about perpendicular lines. So, first, what are parallel lines? Well, two lines in the same plane. You'll learn more about what that means in geometry. The important part for now in algebra is that they never intersect. Notice how the red line and the blue line here are pointing in the exact same direction. And it doesn't look like they're ever gonna cross. So if we have two lines like this, well, it doesn't look like right here they're not crossing it, but if we keep drawing these lines, eventually, somewhere down the road, they're going to cross. So it's not unless these lines are perfectly in the exact same direction, then they will never ever cross. So, what does it mean to be pointing in the exact same direction? Well, two lines in the same plane that never intersect are parallel lines. Two distinct non-vertical lines, and we'll talk more about why vertical lines are a special case in a minute, but two distinct lines are parallel if and only if they have the same slope. So let's go back here for a minute. Notice the blue line is y equals 2x plus 2. So remember that's y equals mx plus b, which means that m, or 2, is the slope. So in the blue line, the slope is 2. In the red line, the slope is also 2. So any parallel lines, anytime you're talking about parallel lines, they have the same slope. Make sure you write that down because it is very, very important. All vertical lines are parallel. Now, we can't talk about vertical lines having the same slope because vertical lines have an undefined slope. So what does it mean for two undefined slopes to be equal? Like, no, you can't do that. So, we just say, like, and we know all vertical lines are parallel. It's not because they have the same slope, because they have an undefined slope. It's just because we can see that if two lines are perfectly vertical, they're never going to cross. Okay, all right. So parallel lines are the same if they have the same slope. If they have the same slope, then they're parallel. And if I tell you they're parallel, then you know they have the same slope. That's what if and only if means, is it means it goes both ways. If they have the same slope, then the lines are parallel. And if the lines are parallel, then they have the same slope. It goes both ways. All right, now let's jump into our first example using this new information. Identifying parallel lines. Hey, that was part of our success criteria, wasn't it? You will be able to identify parallel and perpendicular lines. So example 1 will be parallel, and then the next example we do will be parallel and perpendicular. So we want to determine which of these lines are parallel. And what we need to do, remember, parallel lines have the same slope. So if we want to know if these lines are parallel, we need to know what their slopes are. So we need to find for line A, B, and C, we need to find m. y2 minus y1 over x2 minus x1. We need to do this for every single line. The red one, the green one, and the blue one. And then we can see, oh, this has a slope of 2, this has a slope of 2. Oh, they're parallel. This has a slope of 3. Oh, they're not parallel, you know. Whatever the slopes turn out to be. So, let's look at the blue line first. We have x1, y1, x2, y2. And now, I'm going to color code. So because part A is the blue line, I'm going to do this in the color blue. So y2 is 2 minus y1 is 3 divided by x2 is 1 minus x1 is negative 4. Now, 2 minus 3 is negative 1. And 1 minus negative 4 minus negative is 1 plus 4, which is 5. So the slope of line A is negative 1/5. Okay, now let's move on to the red line. We have x1, y1, x2, y2. And y2 is negative 1 minus y1 is 0 divided by x2 is 1 minus x1 is negative 3. Now, negative 1 minus 0, that's just negative 1. And 1 minus a negative, so 1 plus 3 is 4. So the slope of line B is 1/4. Is that the same? Is our negative 1/5 and negative 1/4, are those the same number? No. They're close, they're very close, but they're not the same. So lines A and B are not parallel. And if we look on the graph, we can see it really looks like they're parallel. Like, it looks like all of them are parallel. But if we extended these lines forever and ever and ever and ever, oh, and that's kind of curving, isn't it? But if we extended these lines forever and ever and ever, eventually we might not even be able to see it on this. Oh, maybe. Maybe. These lines are not straight. But if we extended these lines forever, they would eventually cross. And we can also see that if we count negative 1, 1, 2, 3, 4, negative 1, 1, 2, 3, 4, 5, we can see that their slopes are not exactly the same, which means that eventually, way down the road, they will cross. Okay, lastly, let's look at the green line. So we have x1, y1, x2, y2. And y2 is negative 5 minus y1 is negative 4 over x2 is 2 minus x1 is negative 3. So, negative 5 minus a negative 4 is negative 5 plus 4, which is negative 1, divided by 2 minus a negative 3. 2 plus 3 is 5. So the slope of the green line is negative 1/5. Hey! That's the same as the blue line. So lines A and C are parallel. And now we don't need to list off all the combinations. A and B are not parallel, B and C are not parallel, A and C are parallel. You really just need to say lines A and C are parallel, the rest aren't. So, lines A and C are parallel because they have the same slope. And remember, that's the most important part, is because their slopes are the same, they are parallel. If the slopes are not the same, they are not parallel. Okay, let's check and see if we were correct. Find the slope of each line, negative 1/5, negative 1/4, negative 1/5. So lines A and C have the same slope, so they are parallel. Awesome, we were right. Time to move on to perpendicular lines, because our learning target and our success criteria talked about parallel and perpendicular. So we're going to talk about the perpendicular piece now. Perpendicular lines are two lines that intersect to form a right angle. And that's what that symbol is right there. That red box in the corner says, this is a right angle. Okay. Now, if you're like, a right angle, what is that? A right angle is a perfectly 90-degree angle. So think about the floor and the wall, right? The wall doesn't slant inward unless maybe you're up by your roof. But like the walls in our school building, they don't slant inward, they don't slant outward, they are perfectly straight up and down. And the floor is perfectly flat. So they meet each other at a perfect 90-degree angle. The ceiling and the wall meet at a perfect 90-degree angle up here in this corner. So that's what it means to be a right angle, is a perfect 90-degree angle. Okay, and how do we know if a line is perpendicular to another or not? Perpendicular lines had the same, parallel lines had the same slope, but perpendicular lines can't have the same slope. We want perpendicular lines to cross. We want them to cross at a perfect 90-degree angle. So, instead of having the same slope, perpendicular lines have, lines are perpendicular if and only if their slopes are negative reciprocals. Negative reciprocals. Woo, okay. I know what negative means, right? You take 5, you put a minus out front, that's negative 5. I feel good about negative. Reciprocal, what did that mean? Well, the reciprocal of a number is flip the top and the bottom. So the reciprocal of 2/3 is 3/2, because I took the 3 and I put it on the top, and I took the 2 and I put it on the bottom. I flip-flopped the numerator and the denominator. That's what a reciprocal is. Now, what about the reciprocal of 8? There is no top and bottom, so how should I flip-flop the number 8? Is the reciprocal of 8 8? No. So you can think of 8 as 8/1, right? 8 wholes is a way that you can think about it. And wholes with a W. 8 whole units. Okay, so we can think of 8 as 8 over 1, because 8 divided by 1 is 8. Okay, which means that if I flip that, I get 1/8. So the reciprocal of a fraction is flip the top and bottom. The reciprocal of a whole number means put it underneath a 1. So the reciprocal of 5 would be 1/5. The reciprocal of 2 would be 1/2. Okay. The fancy definition of a reciprocal is it is the number that when multiplied by, so if I multiply 2 by its reciprocal, I should get -1. That's what a reciprocal is. And if that doesn't make sense, don't worry about it. You don't need to understand this. You just need to understand how to take the reciprocal. But this will be helpful if you plan to go on into more math, college math. You'll want to start thinking like this in terms of fancy definitions. Okay, so notice how in the diagram they give us, we have y equals -2x plus 2, and y equals 1/2 x minus 1. So lines are perpendicular if and only if their slopes are negative reciprocals. So the reciprocal of 2 is 1/2, and notice that the 2 is negative, so the other one needs to be positive. And that makes sense because remember that if a slope rises from left to right, it means that we have a positive slope. If the slope is falling from left to right, it means we have a negative slope. If both of your slopes are falling, can they ever be a perfect 90-degree angle? No. So one of your slopes needs to be negative and the other slope needs to be positive in order for you to have perpendicular lines. Parallel lines, they both need to be positive or they both need to be negative. But with perpendicular, I need one to be positive, the other to be negative, so that we have them cross at that perfect right angle. Okay, so reciprocals, one is positive, one is negative. Negative reciprocals. Okay. And again, vertical lines are perpendicular to horizontal lines. This is another special case because vertical lines don't have, right, they have undefined slope, and this has a slope of 0. So, yeah, so it's a special case because 0 times anything will never give you -1. So this doesn't work out. The negative reciprocals doesn't work out with vertical and horizontal because horizontal lines have a slope of 0 and vertical lines have an undefined slope. But we know that if you take something perfectly vertical and something perfectly horizontal, they meet at a 90-degree angle. That's what the floor and the wall is. Okay. Awesome. Let's move on to our last example for today. Now, I know what you're thinking, Mrs. Dodge, there are no pictures here. Our last example had a graph with several lines on it. And you would be correct. This example does not have any graphs in it on purpose because we can find the slope from a graph. We can also find the slope from an equation. So, for example, if I look at line A here, we have y equals 4x plus 2. And remember, this looks exactly like y equals mx plus b, which means that m is 4. And what was m? Oh yeah, that was slope. Boom. The slope of line A is 4. Now, I know I went through that kind of quickly. We noticed that the line was in the form y equals mx plus b, and in y equals mx plus b, m is the slope, which means that m is 4, or the slope is 4. Okay. So, what we need to do is we need to find the slope of lines b and c, and if any of them are the negative reciprocal of 4, then it's perpendicular to line A. So before we even find the slopes of lines B and C, what is the negative reciprocal of 4? Can you figure it out? So, the reciprocal of 4, remember that's like 4 over 1. The reciprocal of 4 is 1/4, but it needs to be the negative reciprocal. So if either of these lines have a slope of negative 1/4, they will be perpendicular to line A. Okay. All right, so line B. This isn't in y equals mx plus b. How can I find the slope if it's not in y equals mx plus b? Well, we can put it into y equals mx plus b. This is going to be a little refresher from section 1.5 on literal equations, because we're going to solve this for y. And if I want to get y by itself, it means that I need to move the x over to the other side of the equation. So I'm going to need to minus x from both sides, and I get 4y equals negative x plus 3. I know you're thinking, wait, shouldn't I do 3 minus x? Remember, if we want y equals mx plus b, the x should come first. So negative x plus 3. And now to get the y by itself, I need to divide by 4 on both sides. So I get y equals, and remember, we take the negative x divided by 4 and the 3 divided by 4. So this is y equals negative 1 x divided by 4, or negative 1/4 x, plus 3 divided by 4. That's how we change negative x plus 3 divided by 4 turns in to negative 1/4 x plus 3/4. All right. So this is the equation of line B, and what is its slope? Y equals mx plus b. M is what is in front of the x, so the slope is negative 1/4. Hey! That's the negative reciprocal of 4. So we know lines A and B are perpendicular. We know that. Cool. Oh, whoops, I'm zoomed in too much. You can't see it. Sorry about that. Lines A and B are perpendicular. Okay, but we're not done yet because we have another line. So is line C also perpendicular to A? We don't know. So let's put line C into y equals mx plus b form. Let's solve for y. So first I need to move the 2x over. I'm going to add 2x to both sides. That gives me negative 8y equals 2x plus 16. And now, remember, I want to get y by itself, so I need to divide by negative 8. And that goes away on the left. I get y equals, what is 2 divided by negative 8. Let's see. 2 divided by negative 8 is negative divide by 2 on the top and bottom because they're both even. I know I can do that. 2 divided by 2 is 1, and 8 divided by 2 is 4. So negative 1/4 x, and 16 divided by negative 8 is negative 2. So the equation for line C is y equals negative 1/4 x minus 2. And remember, if we look at y equals mx plus b, the m of this equation is negative 1/4. So the slope is negative 1/4. Ta-da! And that is the negative reciprocal of 4. So we can say lines A and C are also perpendicular. And we can say even more because it says determine which of the lines are parallel or perpendicular. Well, hey, lines B and C have the same slope. So we also know lines B and C are parallel. So our final answer is kind of all over the place. But lines A and B and A and C are perpendicular, and lines B and C are parallel. Let's check and make sure that we were right. Yeah, lines B and C are parallel. Line A has a slope of 4. Negative reciprocal is negative 1/4, so it is perpendicular to lines B and line C. So it didn't show you how it got from one to the other, but we did. So you can go back and look at our notes if you want to see that. All right. That is all I have for you today. And of course, what I would like you to do now is rate yourself on a scale of 1 to 3, where 1 is I don't know what's going on, and 2 is I need to try the homework, and 3 is woo, I understand fully. Where are you at? And take the appropriate action based on where you are. So if you're a 1, ask for help. If you're a 2, try the homework. And if you're a 3, help your friends or teach your parents about what you learned. Okay, these are some practice problems you can do to practice the problems you learned in this video. So the first set of problems right here is the same as example 1. It's just, are the lines parallel or not? And it gives you several different types. So we have some with graphs, we have some where it just tells you the points, and we have some where it tells you what the equations are. They do the same for the second set of questions, and the second set of questions is like example 3. So are they parallel or perpendicular? So in example 3, you're looking at parallel and you're looking at perpendicular, whereas the first example, you're just looking at parallel. Okay, let me clean this up so that you can see it easier. And yeah, practice those if you would like to. But of course, do the homework that your teacher assigns as well. And as always, let's end our video with a launch. Today's launch comes from H. Jackson Brown Jr., and he says, life doesn't require that we be the best, only that we try our best. So, it can be very discouraging if we focus on being the best, because odds are we're not gonna be the best, right? If we're the best, that means that we are the one person in the world, in the entire world, that is the best at that thing. odds are that's not going to be us. There's only one gold medalist at the Olympics. There's only one, you know, person that wins the most Grammys or whatever. So being the best, life doesn't require that we be the best. And how do we even know if we're the best? You might be the best singer, but you just don't have a record label or something, right? The people with the record labels are the ones that are making music. And maybe you're better at singing than them, but we don't get the opportunity to hear your voice. So how do we even tell? How do we even know if we are the best at something? That's too hard to measure anyways. So instead, don't focus on being the best. Focus on trying your best. And don't use this as an excuse. Like, oh, I tried my best. A 39% was the best that I could do. Sometimes that is the case. And sometimes it's people being lazy, like, oh, I did the best that I could. If you are truly trying your best, you are not going to stop until you've got it. If you are truly trying your best. And there are some things that we don't need to try our best at. Personally, I don't need to try my best at cooking salmon. That's not something that's important to me. I don't even like shrimp. Why would I try my best at cooking shrimp? I don't like shrimp. It's not worth it to me. I'm not going to try to be the best swimmer. I enjoy swimming. I don't need to be the best at it. That's something that I can, let go of. But I do want to try my best at being an amazing teacher. Years from now, I want to try my best to be the best mother. And I'm not going to stop learning. I'm not going to stop reading books. I'm not going to stop growing until I, feel like I am a good teacher and like I am a good mother. And as long as you continually try to be the best wife, the best girlfriend, the best significant other, whatever, as long as you keep trying and keep getting better and keep growing, that is what life requires from you. Not that you magically know how to ace every math test, but that you keep trying and you keep working your hardest until you are satisfied with where you're at with whatever it is, whether it be your math grade, your significant other, or being the best teacher you can be. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.